Yes. Today we will discuss about the stereochemical aspects of nucleophilic substitution reaction. As we have studied earlier that in SN2 means substitution nucleophilic bimolecular reaction, we get the product that is invert in the configuration, while in SN1 reaction the product is a racemic mixture of two configuration, racemic mixture that is optically inactive also. To understand these terms, that what is inversion or what is racemization or what is retention, we have to learn some basic points. First is plane polarized light. What is a plane polarized light? You know that a simple light is an electromagnetic wave, radiates in all the direction like this. If we pass this ordinary light through a Nicol prism, we get a light waves that has vibration in any single plane. That light is known as plane polarized light. Second term you should know is optical activity. What is an optical activity of a compound? Then if a plane polarized light is passed through a certain compound solution, it rotates the plane of plane polarized light either towards right or towards left. Means compounds that rotate the plane of plane polarized light when it is passed through their solution is known as optical active compound. And the angle of rotation is measured by the instrument known as polarimeter. As I was telling you that when we pass the PPL means plane polarized light through a compound solution, it can rotate. If it is an optically active compound, it can rotate the plane polarized light towards right or left. Then if it is rotating the light, plane of plane polarized light towards clockwise direction, it is known as dextrorotatory, noted by D or plus sign. And if it is rotating the plane towards left or anti-clockwise, it is known as levorotatory, L denoted by minus sign. Fine, means DL and L minus. These are the two isomers of a compound are called as optical isomers. And this phenomena is called optical isomerism. Fine. Now, from where this optical activity or optical isomerism, this concept came from, then you have to go back. And I'll tell you a story about Louis Pasteur. Louis Pasteur in 1848, he was just working on crystals. He was working on crystals and he found out that certain compounds have crystals that are mirror image of each other. Mirror image of each other. Then what he did? He separated these crystals. He separated these crystals and make the solution of these two. Means solution A and solution B. These crystals of the same compound, but they are mirror image of each other. And when a plane polarized light was passed through them, they both the solution rotate the plane but in opposite direction. Then it was observed that okay, then first time the concept of optical activity was raised, and it was formed that because of the configuration on different configuration, this phenomena is occurring. And Louis Pasteur, you know that he is known as the father of stereochemistry also. Then next concept you should know is chirality. Chirality is what? Any objects that are non-superimposable on their mirror image are known as chiral molecules or chiral objects. And the property is known as chirality. While any object that is superimposable on mirror image is known as achiral. I'll show you a figure or I'll show you a picture. This you can see in this one hand and the mirror image of hand. If you want to superimpose one hand and its mirror image, it will never superimpose like this. These are two hands looking like the mirror image. If I want to superimpose it, it will not superimpose. That means these are achiral, which is chiral zone. And if you want to see the molecule, this is a carbon molecule having 4 different tetravalency, 4 different valencies. Its mirror image will not superimpose on this molecule. It is also known as chiral molecule. In 1874, Levell and Vantoff, they were 2 scientists working in different laboratories. They found out that carbon molecule is tetrahedral in nature, and also found that if all the 4 valencies of carbon are satisfied by 4 different groups, it is known as asymmetric carbon or chiral carbon. Please do not confuse this chirality with chiral carbon. Chiral carbon is a different thing and chirality is a different thing. And only having a chiral carbon or an asymmetric carbon is not becomes the basis of a molecule of being optically active. But it is also a fact that if any molecule has 1 chiral carbon, it will be definitely optically active. That means, what are the basic conditions of a molecule to be optically active? These are 2 conditions. Number 1, it is a non-superimposable onyx mirror image. It is very important that any molecule, if it is an optically active, it will never superimpose on its mirror image. Point number 1. And point number 2, it should not contain element of symmetry. Or in simple language I will say, you cannot cut it in 2 equal half portion. Means I have already written here, plane of symmetry means by any plane you cannot divide it in 2 equal halves. If any molecules is having 2 properties, means non-superimposable mirror images and does not contain element symmetry, this molecule will definitely be optically active and it will rotate the plane of plane polarized lights either toward right or either toward left. Now third, what is enantiomers? These stereoisomers of optically active compound related to each other as non-superimposable mirror images are known as enantiomers. These are known as enantiomers. As I have given the example, suppose it is butane 2-ol. These 2 enantiomers are here. 1, these are mirror images of each other but are not superimposable mirror images. Therefore, these are enantiomers. One is L or one is D. Enantiomers. What is the properties of enantiomers? Their physical properties are identical. Means these 2 enantiomers, they are identical in physical. They have same boiling point, they have same melting point, even the solubility property is same. The only difference in the enantiomers is that it rotates the plane of polarized light in opposite direction. Suppose if this enantiomer is rotating the plane in right direction or clockwise direction, then this enantiomer or the mirror image enantiomer will rotate the plane of plane polarized light in anti-clock direction. Then the racemic mixture. What is the racemic mixture? If these 2 enantiomers are taken in equal proportion in a solution, then their rotation will cancel out each other and they will have 0 optical rotation. Such mixture is known as racemic mixture and is noted by like this plus minus sign. Now in this figure I will explain what is the inversion of configuration, retention, and what is racemic mixture. Suppose I have taken this example. Carbon has 4 different valencies, attached with 4 different groups. One is methyl, hydrogen, ethyl, and an unknown group, any unknown group. Means it is a chiral carbon. It is a chiral carbon. It will not be superimposed onyx mirror maze. That means it will show optical activity. Now, what can happen? What can happen if we attach a Y? Y molecule is attacking on this molecule. Either this will be the case, A will be the product or B will be the product. In A, in product A, the Y is replaced X at the same position, at the same configuration where it was first situated. As you can see in this kind of configuration is known as retention of configuration. While in the case of B, Y is attacking this molecule and is placed on the opposite side where the X was placed. On the opposite side where the X was, or the leaving group was placed. This configuration is known as inversion of configuration. And third case may also happen if Y is attacking this molecule and you get a mixture of A plus B, and if it is 50-50 mixture, you will get no optical activity and it will be known as racemic mixture. Now, we will take the example of SN2 and SN1 reaction mechanism. In SN2 reaction mechanism, we have told you that there will be a inverted configuration in the product. How it is? You can see in this. I have taken -2 bromo-octane as an example. -2 bromo-octane. That means it is levorotatory and bromine atom is placed here. Now OH is attacking. Now you can see in the product that the configuration of the reactant has been reversed or opposed, and it is now become plus octane 2-ol, means from levorotatory to dextrorotatory. This is known as inversion. As I have told you earlier that in SN2 reaction mechanism there will be complete inversion of the configuration. In SN1 I have told you that there will be a racemic mixture formed. What do you mean by racemic mixture formed? Because in SN1 there is a formation of carbocation first, and carbocation is what? It is planar triangular nature, means when nucleophile attack on carbocation, it can attack from both the sides, either from up or below, and you will get both kind of configuration. One is retention and one is inverted. One is retention and one is inverted. And in carbocations, because there are 50-50 chances of nucleophile to attack from upside and from below side, means you will get a racemic mixture. This is all about the stereochemical aspects of SN1 and SN2 reaction mechanism. Thank you.